Add distance and midpoint to your table of contents, and add the following to your formula facts. Distance is d equals the square root of x minus x squared plus y minus y squared. And midpoint is x plus x over 2, y plus y over 2. The distance formula can be used to find the distance between 2 points on the coordinate plane. Your distance formula, again, is d equals the square root of x minus x squared plus y minus y squared. On the actual formula, it does say x2 minus x1 and y2 minus y1, but those subscript numbers are really there just to be picky. For example, if you had 3, 4, and 1, 2, and you were finding the distance between those, as long as when you plug in an x, say for instance, if you chose 3 as your first x, then you would need to choose 4 as your first y. So basically, if they are together in a set of parentheses, they need to go in the same location when you plug into the distance formula. If you wanted to go with 1 as your first x, then you would have 1 minus 3 squared plus 2 minus 4 squared. Looking at an example, here on your picture, you have this point at 2, 2, and this point at 6, 5. And so if you wanted to find the distance between the point 2, 2 and the point 6, 5, what you need to do is plug in your x and your y's into your distance formula. So you would find the square root of 2 minus 6 squared. 2 is an x and 6 is an x. 2 is a y and 5 is a y. Plus 2 minus 5 squared. So you keep going, say 2 minus 6 gives you negative 4 squared. Plus 2 minus 3, which gives you negative 3 squared. Excuse me, 2 minus 5 gives you negative 3 squared. So your negative 4 squared is really negative 4 times negative 4, which would give you positive 16. Negative times a negative is a positive, and 4 times 4 is 16. Negative 3 squared would be the same as negative 3 times negative 3. Negative 3 times negative 3 would give me a positive 9. So 16 plus 9 gives me 25, so I'd have the square root of 25, which would give me 5, because 25 is a perfect square. So the distance between the points 2, 2 and 6, 5 would just be 5. On your first example, it says find the distance between negative 3, 1 and 2, 3. So the first thing you need to know, since it says distance, you need to know the distance formula, which would be x minus x squared plus y minus y squared. The next thing you need to do is label your x's and y's. So remember that a point has an x and a y. The first number that you see is your x. The second number is your y. So when you go to plug it into the formula, it looks like negative 3 minus 2 squared plus 1 minus 3 squared. Negative 3 minus 2 gives you negative 5. And 1 minus 3 gives you negative 2. Negative 5 squared is the same as negative 5 times negative 5, which would give you a positive 25. Negative 2 squared is the same as negative 2 times negative 2, which would give you a positive 4. (25) plus 4 gives you 29, so you've got the square root of 29. 29 is not a perfect square. And I also can't break down 29 in a factor tree. But I can give a decimal approximation of the square root of 29. If I were doing the square root of 29 on a calculator, it would give me 5.385164807. Let's say that we wanted to round it to the nearest hundredths place, which is 2 places after the decimal. I would look at the third number after the decimal, and if it was a 5 or bigger, I would round up the second number. So in this case, my third number is 5. That means that I would round up that 8 to a 9. So the square root of 29 is approximately 5.39. On your second example, it says find the distance between negative 2, 1, and 2, 5. Since it says find the distance, you're going to use the distance formula. X minus x squared plus y minus y squared. Label your points x and y, and then you can plug them into the formula. So negative 2 minus 2 squared plus 1 minus 5 squared. Negative 2 minus 2 would give you negative 4, so you'd have negative 4 squared. And 1 minus 5 also gives you negative 4, so you'd have negative 4 squared again. Negative 4 squared is as good as negative 4 times negative 4, which gives you positive 16. So since this one's also negative 4 squared, it would also be positive 16. 16 plus 16 gives you square root of 32. 32 is not an example of a perfect square, which would mean that it would come out to be a whole even number. But I can break down 32 using a factored tree. Two numbers that will multiply to give me 32 would be 8 and 4. I can keep going because I can break 8 down to 4 times 2. And I can break 4 down to 2 times 2. I can keep going again because I can break that 4 down to 2 times 2. So then I end up with a whole line of 2's. But in order for me to put them in a group, I need to know what the index number is on the outside, which is an imaginary little 2, which lets me know I'm going to put two numbers that are exactly the same in a group. So I have one group and another group. That 2 doesn't have a group number, so it stays where it is. What I do with my groups is I'm going to take one from the group and cross the other one out. Remember, since I was multiplying inside, I'm also going to be multiplying outside, so any numbers that go outside the square root are going to be multiplied together. So when I take one from this group, I'm going to take out another 2, cross that out. So I'd have those two numbers being multiplied together, but I didn't do anything with that 2 that was still inside, so I leave it where it is. 2 times 2 gives me 4, so square root of 32 is 4 square roots of 2. I could also get a decimal approximation by plugging in square root of 32 on a calculator, which would give me 5.656854249. But if I wanted to round to the nearest hundredths place, I would look at the third number, which is a 6. That would bump that 5 up to a 6 also. So the square root of 32 is approximately 5.66. Either of these answers would be correct. The midpoint formula is going to give you the point that is exactly in the center of a line segment. So we say that the midpoint is equidistant from the endpoints. Equidistant just means the same distance from each endpoint. So your midpoint formula is going to be x plus x over 2, y plus y over 2. Remember, it's midpoint, and so that's a point, which means that it has an x and a y. And so to get your x, you just take your x's and add them together and divide by 2. To get your y's, you do the same thing, add them together and divide by 2. So on this picture, it's kind of easy for us to find out where our midpoint is, but you're not always going to be so lucky. They're not always going to give you a picture. And sometimes even when they do give you a picture, your picture could be drawn off to scale. So if I wanted to find out exactly where that midpoint was and I didn't want to rely on the picture, I would start out by taking this endpoint, which is at 3, positive 3. Excuse me, that's 2, positive 3. The other endpoint, 2, 3, 4, 5, 6, 7, is at 7, positive 5. I need to know my x's and my y's. Remember, x's are always first, followed by y's. To find out what that midpoint was, I would say 2 plus 7 divided by 2 and 3 plus 5 divided by 2. So take my x's, 2 and 7, add them together, divide by 2. Take my y's, 3 and 5, add them together, and divide by 2. I can keep going. 2 plus 7 gives me 9 divided by 2. And 3 plus 5 gives me 8 divided by 2. 9 over 2 doesn't reduce, but it can be written as 4.5 or 4.5. 8 divided by 2 does reduce, and it reduces down to 4. So the midpoint should be at 4.54. Looking at my picture, I can find out where my M is, where my midpoint is. 1, 2, 3, 4, and looks like a half. And then 1, 2, 3, 4. So my midpoint on my picture did lie at the point 4.54. Like I said before, though, you're not always going to be given the picture. So in example 3, we need to find the midpoint of a line segment with endpoints at -3, -1, and 7, -5. So since it tells me midpoint, I need to remember my midpoint formula, which is just going to be a point, x plus x divided by 2, and y plus y divided by 2. Whenever you have your answer, it's important that you put parentheses and the comma in your answer because, remember, it does represent a point. So your x's and your y's are in your problem. Your first number is your x, second number is your y. So when you go to plug it in, you're going to have -3 plus 7 divided by 2, and then -1 plus -5 divided by 2. -3 plus 7 gives me +4 divided by 2, and -1 plus -5 gives me -6 divided by 2. 4 divided by 2 is going to just give me 2, and -6 divided by 2 is going to give me -3. So the midpoint for a line segment with endpoints at -3, -1, and 7, -5 would be 2, -3. On example 4, I'm finding the midpoint of a line segment with endpoints at 6, -3, and 4, -7. So your midpoint is going to be x plus x divided by 2, y plus y divided by 2. 6 and 4 would be my x's, -3 and -7 would be my y's. So I'd have 6 plus 4 divided by 2, and then -3 plus -7 divided by 2. 6 plus 4 gives me 10 divided by 2. -3 plus -7 gives me -10 divided by 2. I can reduce both of those by saying 10 divided by 2 gives me 5, and -10 divided by 2 gives me -5. So my midpoint for line segment with the endpoint 6, -3, and 4, -7 would be 5, -5.